So good morning, and thank you for joining us for our Specifying Low Carbon Ready Mix Concrete in Ontario webinar. It's a very exciting topic, and there's still a lot of questions about what is low carbon concrete, what is involved in actually specifying it, and then most importantly, how do we use a specification or information relating to specifying it to actually achieve carbon reduction goals on a real world project. Now, these are some questions that we're going to tackle today. And we're also going to introduce a brand new resource, which we just released yesterday, just in time for this webinar, a little bit later. But before we get into all that, let's start off with some housekeeping items. So the presenters today are myself, Alan Carey, Director of Technical Services at Concrete Ontario. We also have Bart Canters, who's the President of Concrete Ontario. So good morning, Bart.
Thank you.
Bart will be doing a portion of the presentation. In terms of the housekeeping itself, so it will be approximately a 45-minute webinar. We'll leave some questions, time for questions and answers at the end. All participants are muted and will remain that way for the entire webinar. If you do have a question, please use the GoToWebinar questions pane on the right side of your screen and type in your question. We will address all the questions at the end to keep things going. The webinar is being recorded and will be posted on the Concrete Ontario website along with a PDF copy of the presentation. So if anybody did miss this webinar, they can definitely get caught up tomorrow. And a follow-up email will be sent tomorrow to make access to the recording and the PDF presentation a lot easier for participants. So that typically goes out about 10 a.m. tomorrow. Now, for this webinar, it is a bit more of an advanced webinar compared to what we did in the past. So attendees should be familiar with the following. What is embodied carbon? What are EPDs? Questions related to the Ontario Industry Average EPD report. So all this information was covered in our September 20th webinar, which is available on our website. So we do encourage everyone to check that out if you haven't already. But as mentioned, today's webinar will take all that information into account, and all those concepts will be applied to the information we're presenting. The agenda for today, so what is low carbon concrete? Bart's going to be tackling that. He'll also look at how do you actually specify low carbon concrete in terms of performance-based specifications. He'll look at the concrete raw materials that are involved. He'll also discuss early strength development concrete, which is a huge portion, especially in our climate. And then I'll tackle the concrete carbon project budget, as well as a condo case study at the end. Now, the resource I did mention at the beginning is available now. So it is our concrete carbon guideline for specifying low carbon ready mix concrete in Ontario. It's a brand new document. It is available for download in the handout section on the right side of your screen. So everybody does have access to this new guideline. And again, this guideline is an evolving document. It reflects the latest information that we have as an industry when it comes to specifying low carbon concrete, being transparent with EPDs. And then we are providing a suggestion on how all that information can be used through a case study, which we will cover in today's webinar. So now I'm going to turn it over to Bart, who will be looking at what is low carbon concrete. So Bart, I'll give you controls here.
Excellent. Thank you, Alan. And again, we want to thank all the members of our technical committee that assisted the association in pulling these documents together. And now we're going to try and walk through, click on here, what the changes are. So again, we're going to start off with the obvious. Concrete is a very low carbon material. We're using local sand and stone and cement to create very durable construction material. The real fact, one of our primary objectives is because concrete is the most used construction material in the world, there's this very significant quantity of it. So any carbon reductions that we can implement when it comes to actual Ontario projects can have a huge impact to the overall environment. And that's really what we're trying to address here. So we won't get into the reasons why we use it. Again, durability, it's synonymous with durability and strength and resiliency. Those are all critical technologies. And really what we're trying to do is address the transparency issue. So the cement and concrete industry have committed to a net zero target for 2050. And the very first step in that process is to be very transparent as to what our carbon impacts are. So that's what we're going to try and address today, and we're going to talk about how you can implement it on the job sites. So you're going to get the feedback from some contractors and some concrete producers of, what are you talking about? We've already been implementing low carbon concrete. So we're going to go through that and discuss those issues. Really what we're trying to do is we're trying to optimize the materials and the mix design with the overall structural design and the contractor requirements on the job site, which are based on schedule and also based on time of year and weather conditions on the job site. So again, there's a lot of interaction. This is not a simple process of let's just go across in a table, read a number and go, there we go, we're good to go. So we're going to go through and talk about that. So really what we want to do is identify how can we still meet all of the performance requirements. And now really what we're adding in is a new evaluation system. We're adding carbon as a performance requirement for the projects. So moving along, whoops. I'm going to step back, and a lot of these issues relate to all concrete projects. But when it comes to project success, again, first thing is having a very qualified concrete supplier. So again, the association runs a plant certification process, and we certify both trucks and concrete plants to supply concrete. So that's our first step, is using a qualified supplier. Next, the designer has to identify what's their structural or long-term durability performance requirements, what's actually needed of the concrete. So again, they have to spell that out. Then the concrete producer and the contractor have to partner together to address the constructability issues. So we've got an overall compressive strength or a linear shrinkage requirement for the concrete, but now we've got a 3-year job and the contractor has to build during multiple construction seasons the project. How are we going to deal with the actual challenges on the job site, and deal with the way that the contractor actually plans on building the project. Again, it's typically still a low bid situation that wins contracts. So again, there has to be a lot of interaction in the project team out on the job site. We're going to get into submittals to try and show that we've identified what the performance requirements are. And then we're going to get into quality assurance testing. So again, testing remains one of the critical issues for our industry. As we talk about low carbon reductions, one of the major levers that we're pulling, quite simply, is trying to optimize the mix design for cement content. And we're trying to optimize or reduce for cement content because it has a fairly significant impact on the carbon intensity. So we have to have accurate concrete testing in order to do that. And then responsibilities. Who's responsible for what? And again, we're used to compressive strength. We're used to other performance requirements. We're used to delivery challenges out on the job site. Now we're going to add in low carbon as a requirement. So really what we see is it's another option for using performance specifications. Again, specifications give the contractor and the concrete producer the flexibility to address the specific site situations. And Alan's going to show that in the case study that he's going to go through later in this presentation. So again, prescription and performance, the CSA concrete standard allows for both. 99% of the time we follow the performance option. There's a few exceptions where we go the prescriptive route. But really what we want to stress when it comes to low carbon concrete is performance is the way to go. We do not want to see people thinking that it's low carbon concrete is as simple as specifying 50% supplementary cementing materials. That's not the way to approach this. That will result in significant challenges, and we'll go through and talk about that. Really what we have to try and do is go through the constructability requirements, the performance requirements, and the low carbon requirements. And the performance system is what gives us the ability to do that. And we're going to show that with an example. So if we jump back to the standard table, it's all identified in CSA with the exception of item number 6, which is the new sustainability requirement we put in. But again, things really haven't changed that much. We're typically seeing from a design requirement, a compressive strength is going to be specified. Again, the The designer has the ability to indicate the age, but the contractor is going to have a say on when that strength is required because it relates to constructability. We're going to identify durability requirements when it comes to different exposure classes. Those still have to be met. We're going to identify if you've got high performance requirements and you want to go above and beyond what the minimum requirements are in the code, then you can identify those performance requirements and we can test for that. Volume stability, shrinkage, cracking, those are always issues that we address. Architectural requirements, again, we see a lot of self-consolidating concrete and exposed concrete elements. There's a lot of really good reasons to utilize those products. And again, we need to be aware of what the performance requirements are. The sixth one that we're adding in is sustainability. So really what we're trying to address is how do we deal with if global warming potential or kgs of CO2 per cubic meter is the primary new metrics that we want to add into the discussion when it comes to the project, then how do we identify that? How do we set targets? And then how do we monitor during the actual construction process? And that's probably the bigger challenge. Again, we can get into pre-qualification. So if you want to see pre-qualification testing, we can still do that. Quality management system. So again, evaluating the in-place concrete or the supplied concrete at the end of the chute. Those are critical aspects. They need to be dealt with in the specification. And we move our way along. So pretty straightforward. When we get to evaluation, the very first one that's going to come up here is communication and evaluation. So as soon as you start to set a limit when it comes to what's the total amount of carbon in the concrete that we're supplying to the job, now we have an interaction between the designer, the contractor, and the concrete supplier. And in our previous webinar, when we showed our industry average EPDs, you saw two different cement types, GU and GUL, and you saw supplementary cementing materials ranging from 0 to 50% slag, because that's the primary material we use here in Ontario. You cannot just pick a number out of the table. You have to address things like what's the construction schedule that the project needs to follow? What's the weather conditions out on the job site? We need to make adjustments in February when it's -20 versus July when it's +30. Again, there's different levers that we can pull when it comes to trying to reduce the carbon intensity of the material that we're supplying out to the job site, but we have to communicate. So implementing low carbon concrete specification requirements is going to result in more communication, more site meetings, more evaluations to make sure that we're on track and we get the actual performance that you're looking for. Next, we're going to step back and we're going to evaluate the raw materials. So again, this is a discussion with the entire construction team. Concrete, we typically use local construction materials. We have 5 cement plants in the province. We use aggregates that are on average within a 40-kilometer radius of where the concrete plant is located. So again, we're going to look at the materials and see what are their carbon impacts. So using the example here, we have the ability to use either GU cement or GUL cement. As you look at the study that we produced, the guideline document, you'll see we're on average. It varies depending on what the cement content is for the mix. So the higher strength mixes, it has a bigger impact. But looking at the example that I have here on the screen, just switching from GU to GUL gives you a 6.5% carbon reduction when it comes to the concrete out on the job site. Next major lever that we can pull is supplementary cementing materials. So what can we do when it comes to the use of supplementary cementing materials? Again, these are not new products. We've been promoting supplementary cementing materials for 40+ years. There's a lot of other performance benefits that supplementary cementing materials like slag, fly ash, and silica fume offer to concrete performance. So again, this is not a new thing. If I go back to that example, if you talk to any concrete producer or contractor who was doing mass concrete, we've been supplying 70% slag to mass concrete elements to address the issues around thermal cracking. The carbon intensity of that 70% slag mix design is extremely low, and you've been using it for decades now. So again, we won't get into the technical specifics of where supplementary cementing materials benefit, but again, that's one of the discussions we're going to have on the job site. So again, if we go back and look at simple examples here, if we're looking at changing the cement type and the SCM usage, you can see fairly significant impacts. So again, this first example here, 25 MPa concrete with GU cement, you make this switch to 35% slag, and you see a 25% reduction in the GWP value for that mix. If you make the switch to GUL and 35% slag as shown below, that jumps up to 29% reduction in the carbon intensity for the concrete mix. So again, in a performance system, what we want to get down to is using these GWP numbers as the target and the evaluation system. We don't want to say, well, okay, don't take away from what I just said. Always use GUL and 35% slag and your work is done. That's not the way it works, because you've got all of the site issues that you have to deal with. So what's the downside to using more supplementary cementing materials? It's not really a downside. It's more what's the impact, what impact does it have on the plastic properties of the concrete and the early strength development. So again, when you go through the guide that we've prepared, you'll see simple things, more slag, for example, if we're talking about slag, the more slag we add, the slower the hydration rate we're gonna have, the slower the early strength development we're going to have. It's going to extend out set times. So again, we've got to balance that off with what the contractor needs on the job site and what the outside weather conditions are. So again, we've got some fairly significant temperature swings in the province, and we have to try and address that. So again, lots of opportunities here, but as soon as the contract is awarded, we're basically going to have to get into pre-construction meetings about, okay, when are we starting? What's your draft concrete pouring schedule look like? And let's see where we can optimize the mix designs based on your construction schedule and the weather to try and get these carbon reductions that we're looking for here. Aggregates, another major component. Again, they make up a significant percentage of the concrete. Again, basic theory, if we're lowering the paste content in the concrete, we're reducing the carbon intensity. So using larger aggregate size has a positive impact. Does that mean we're going to go out and move to 40 mil aggregate for absolutely everything we construct? No. But again, there are opportunities there. If there's applications where larger aggregate sizes make sense, we can look at that. If there's opportunities to use not just say a fine and a coarse aggregate to blend multiple sands or multiple coarse aggregates together to try and optimize aggregate gradation, that's another opportunity to have a positive impact on the carbon reduction on the concrete. And again, simple things like recycled concrete aggregates. They're not used extensively right now. There is crushing involved to process those materials, but typically we're crushing those materials right in an urban center, very close to where we're going to use the materials. So we've got drastically shorter transportation distances to be able to use those. So again, if we're producing an EPD for the product with that recycled material, we don't need to think about, well, what's the balance and is it better or not? The numbers will show whether it's a better option or not, and that'll be clear for everyone to see. Last major issue, again, chemical admixtures. They've been a huge benefit to the concrete industry. There's huge optimization options for this, but again, it's dependent on schedule, it's dependent on weather conditions, it's dependent on amount of time that it takes to place the concrete. There's a lot of factors on the job site. The flexibility of concrete is the fact that it's a plastic product shipped out to the job site that takes whatever form you can envision, and then over hours it gains strength to the point where it can both support itself and then support the loads that are applied to whatever it is you're building. There's also innovative new carbon sequestration systems that are coming online. We'll talk a little bit about those later. But again, all that needs to be captured in the environmental product declaration. So next we get into what are the different types of environmental product declarations that are out there. So as an association, what we've produced in our industry average is an industry average, a hypothetical concrete plant. So we have 270 concrete plants in the province of Ontario. 80 plants participated in our study. And basically we averaged all the inputs from those 80 plants to create the one hypothetical concrete plant that we use to generate our industry averages. So once we had the average amount of diesel fuel, average haul distance for sand, average haul distance for stone, average haul distance for cement, amount of natural gas burned at the plant during winter construction, all those factors went into the design, and then it lets us come up with industry averages. The second component that we have as part of that process was then to come up with average mix designs, which we'll show in the table in a second. So industry average is what we've produced. While it's the least accurate at the project level, it's more accurate at the provincial level because we're accounting for multiple concrete producers, multiple concrete plants, and multiple regions in the province. Next one is a type 2 EPD. So with the type 2 EPD, it's a self-declared EPD. The concrete producer is identifying, they're using the specifics of their actual plant in order to generate an EPD. And then the next one is the type 3. It's the most accurate EPD that can be offered. So again, it's plant specific, exact raw material specific, exact haul distance specific, exact amount of diesel fuel per cubic meter that's typically used at that plant specific, and it's verified by a third party. So ultimately what we're seeing is a very strong desire for type 3 EPDs to be used, especially for life cycle cost analysis. Again, we want more accurate data, but what the association has produced is this industry average. And again, we'll go through and talk about these a little later when we get to the example. So going back to the industry average that we've prepared, I guess the million-dollar question is, what do we get out of that? And one of the key things that we get out of our industry average for Ontario is the baseline global warming potential values. So I've pulled up the 40 MPa concrete with air information. And what you could see here as we look across is here's the baseline. The baseline is assumed to be GU cement with 15% slag. So again, we took the data from the 2020 production year, and for all of the 40 MPa concrete produced, we got an average of what was the average amount of slag used. In the summer, you use more. In the winter, you use less. And again, it's an average over the whole year. It averaged out to 15% slag for the whole year. So we've developed an EPD using the industry average concrete plant, and those actual average slag replacement levels, that's what the benchmark is. So again, we're trying to address the fact of we don't want to be greenwashing. We don't want to say all concrete has 0% supplementaries and it's all the worst possible case. That's not what it is. We want real numbers to compare to and to set as a benchmark. So that's what you get out of this table. The rest of the information in the table, as I mentioned before, relates to quick and dirty calculations. So you see next 4 columns relate to GU usage with varying amounts of slag. So 0% slag, the number is 407. We add in 50% slag, it drops down to 361. You move up to 25% slag, 331, etc. So you've got some information here about what is the impacts with varying levels of slag and GU, and then we move over to GUL. And again, you'll see lower numbers for the GUL because it has a lower carbon intensity as a raw material to start with. And again, we go through the same thing, 0, 15%, 25%, 35%, and 50% slag. So again, those are great discussions at the preliminary stage. Often what we're finding is people go, well, that's great. What's your actual information? I want to see your type 3 EPD information for your mixes so we can compare it. But this gives us the benchmark that we need to start the project off and get things going. So next we have to address the issue of what do we do about the constructability challenges that we face in the concrete industry and the fact that we live in a cold weather climate. So again, we're looking at 2 different things. So the US Buy Clean Act, Government Services Administration came out with a table. It relates to PSI and has different compressive strengths, but basically what the US government did earlier this year is they put out documentation saying that when it comes to early strength concrete, if we need early strength in order to remove forms, how are we going to adjust the global warming potential values for those mixes? And what they've said is on average, they're going to increase, we're going to take whatever your benchmark, if we're looking at a 25 MPa suspended slab, and we need 70% of that strength in 48 hours in order to remove the forms, then we're going to allow you to increase the GWP value by 35%, multiply by 1.35, and then that'll be your new target when it comes to what your GWP is. Doing a similar thing here in Canada with the federal government, the Treasury Board of Canada is coming up with a draft specification. The Cement Association and Concrete Ontario have been working with the Treasury Board for the last 2 years, trying to see how can we implement this on real projects. That document is not currently finalized. We're looking forward to seeing that very shortly. In fairness to the Treasury Board, one of the reasons why it's not finalized is the Canadian Ready Mix Concrete Association had to come up with the industry average data for the 7 Canadian regions across the country before they could put out their specification. So end of July, we finished crunching the numbers. Early September, we produced for all 7 regions in the country industry average data. We're here talking about Ontario because that's what we care about, but there's data for BC, Alberta, Saskatchewan, Manitoba, Quebec, and Atlantic Canada. All have different numbers, all use different materials. Again, that's what's important. So what we're seeing in the current draft version, and the reason why our guide is not finalized, we will update it as soon as the Treasury Board finalizes their document, and we're part of the reason why they haven't finalized it yet, then we will update our document to address it. As it currently sits, our understanding is the target will be 1.3. So less than what the US allows, but it's a lot. What we're doing here is we're recognizing for the early strength development, that is going to be a higher impact material. It's required for schedule. There's other reasons why you need that early strength. So we're going to up the benchmark amount to allow for that. As we move along, again, we've got cold weather. So when it comes to cold weather, a significant portion of the concrete produced in the States is not constructed in cold weather. So again, California, Texas, Florida, etc., all the southern states don't have to deal with cold weather like we do. So it's not specifically addressed. What's currently proposed in the Canadian standard, since we do definitely have to deal with cold weather, is that in cold weather, a factor of 1.3 would apply to that as well. And then when we get into specialty applications, the US government for lightweight concrete is currently allowing, again, to make concrete lightweight. What do? You add more air. So air has no strength. So you have to counteract that by increasing the cement content, quite frankly. So what the US government is allowing is an increase by 1.4 or 40% increase in the GWP value for lightweight concrete. Again, for specialized concrete here in Canada, we're looking at 1.3, so a lower value. So now we get down to the guts of this on how do we actually use this on a real job site. So again, when you allow technical people to put together a guide, you wind up with a 65-page document that goes through everything we could possibly think of. We'll have to get the marketing team working on it to reduce the size of that document. But now I'm going to hand it back over to Alan to walk through an example of how we use this so we can get into some questions on how you use it on your real projects. So with that, I'll hand it back over to you, Alan.
Thank you very much, Bart. That's a great introduction to what I'm going to be covering now. Basically, we pulled a project from 2016. We analyzed it in depth of exactly what was poured, mix by mix, and we put together this case study. It is the Met in Vaughan, Ontario, and it was poured in 2016 to 2019. Now, a quick project overview. So it is a 35-story condominium tower. It does have 3 levels of underground parking. There was approximately 30,000 cubic meters of concrete on this project. And more importantly, the 15,000 of that 30,000 was accelerated concrete. Condos are notorious for a changing schedule, an accelerated schedule. They are trying to, do a floor a week, every week or two. So there's a lot of different mixed designs that need to be factored into a project such as this, making it the ideal project to cover in a case study. Now, something I also have to mention is obviously back in 2016, we weren't talking about carbon reduction goals. So that was not discussed at all. And low carbon concrete solutions were not the primary focus. As Bart mentioned, ready mix producers are always trying to optimize their mix designs to achieve low carbon. But now with transparency and everything, we can actually see the numbers. Back then, it was just from an optimization standpoint to give you better performance of concrete. So the primary purpose of this study or this case study is just to look at how a typical project schedule and special application mix designs, which Bart covered, such as cold weather concreting, can impact a concrete carbon budget. In terms of what was actually required for this project, so there was 20 mix designs that were submitted by the ready mix producer to the contractor. But in the end, after you factor in all the variation that was required, there ended up being about 140 different mix designs on this project. Some of the different mix design variations included accelerated set and strengths, enhancement of slumps, aggregate size adjustments were made to accommodate different rebar spacings. Fibers were used, specially admixtures such as corrosion inhibitors and retarders. So overall, there's a lot of different mix designs that were used to really accommodate the contractor's placement needs, schedule needs, and all that's going to be tied into how that would impact the carbon budget. A quick breakdown of the mix designs. So the mix designs range from 15 MPa without air all the way up to about 60 MPa with air. Columns, walls, all the typical applications you would see for a condo are reflected in this case study. And this is just a quick breakdown. Now, all the concrete that was poured on this project was type GU or type GU BSF, silica fume cement, because GUL at that time was not readily available. And we'll showcase how that impacted the project as well. Now, the concrete carbon project budget is something we covered on our last webinar. So if you want more information, please look at that recording. But overall, a budget gives the contractor, the specifier, and the ready mix producer, the flexibility in using different mix designs to really, tackle a demanding schedule and special applications. So the formulas, you're going to see throughout this presentation. You're going to be setting a baseline, which is your CO2e baseline. You're going to be calculating the actual impact on that project, which is your CO2e project. And then based off those two numbers, you will be calculating greenhouse gas reduction for the overall project. So very, very straightforward, but there's a lot more to it once we actually get into the details. And then at the end, you can calculate a % reduction with those numbers to see if you actually achieved your carbon reduction goals. Now, speaking of carbon reduction goals, so it's really up to each owner and specifier, what carbon reduction goals you're going to be trying to achieve. Communication will be critical, as Bart mentioned, between the contractor, the ready mix producer, the owner, of exactly what we're trying to achieve on this project. Bart talked about the Treasury Board, and as a general industry guideline, we are advocating for a 10% reduction on projects currently. That is something the Treasury Board will be putting out in their new specification, which hasn't been finalized yet. But overall, 10% reduction is a reasonable reduction goal currently, as we are still gathering a lot more information about carbon budgeting, whether the baselines are really reflecting accurately how everything is going to work. So we do need a lot more experience and a lot more time to really figure out what are achievable greenhouse gas reduction goals for a project. But 10% reduction is something that is very reasonable currently. So let's go through all the steps of trying to figure out how this project actually did in terms of a carbon reduction goal. So step one for this procedure is to calculate anticipated CO2e baseline. So basically what you need to do, you develop your you have all your mix designs on the project on the left side here, so 15 MPa without air, all the way to down to the 60 MPa. And you're going to have to figure out anticipated volume for all those mix designs. This is, again, any project needs to do this at the beginning to really identify, what concrete will be needed and what quantity. Application, standard, so we'll get into that a little bit later. And then you need to look at all the baselines that are going to be associated with those mixes that you are proposing on the project. So for example, 15 MPa without air, you're anticipating there's going to be 600 cubic meters of concrete for that application. You need to identify a baseline that corresponds to that 15 MPa. Now, unfortunately, the Ontario report does not have 15 MPa baselines. We do have 20 MPa. So that's currently the best we have. So you would be selecting the 20 MPa baseline, and you would be coming up with your anticipated volume of tons of CO2 of 132.2 tons of CO2 for this application. And you go down the list, for example, 30 MPa without air, you'll be consulting the 30 MPa without air baseline, which has 15% slag in it, and you're slowly building your budget. At the end, when you've gone through every single mix design, this project would have showed about 9,200 tons as your anticipated budget. And again, anticipated because you don't know the overall volumes which will be poured by the end of the project. So the baselines are used as a starting point for carbon budgeting, and they should not be used as acceptance or rejection criteria. What does that actually mean? You're building your budget. You don't want to, for example, enforce that a 20 MPa concrete without air, that every single truckload has to meet the 254.05 kgs of CO2 per cubic meter. This is just building your budget. It gives you the flexibility, the contractor and the ready mix producer, to use the mix designs that are required based on scheduled requirements. And overall, it will definitely impact your project at the end. So specifying application-specific GWP numbers is not something that's going to work very well unless you have Type 3 verified EPDs for every single mix design here, which in the future is definitely a possibility. But currently, using the baselines to set a budget is definitely the way to go. So that's step one. Step two is actually adjusting that budget, anticipated budget, to calculate your final baseline for the overall project. Now, this is going to be an evolving process because not all your mix designs are going to be standard application. You will have cold weather, you will have specialty mix designs, high performance mix designs, all those things that Bart talked about when it came to that Treasury Board and GSA specification. So your anticipated baseline will change depending on the mix you're pouring. So in the guideline, you're going to see the first 15 mix designs. They're all standard. So this is covering just the standard volumes of what was actually shipped for this entire project. And the only way to determine that is to go through the entire project. What is your total volume for those applications at the end of the actual project? So your baseline, again, is going to be your volume times your baselines. We have a regular baseline here. Put a tool on. You can see the regular baseline here. And then you have your updated baseline depending on if it is a special application, and that's that 30% increase that Bart was talking about. Okay, let me go to the next slide here. Okay. So next, we need to get into adjusting the anticipated baseline for any special application mixes. So for example, if you do have your 30 MPa concrete without air and it is a special application, for example, you need accelerated set, you need accelerated strength development, now your updated baseline would be 30% higher for that specific application. And your budget will be changing as a result of that. So it goes from 254.05 kgs of CO2 up to 330.27 to reflect, again, the demands of the contractor in terms of setting time, in terms of accelerated strength. That's exactly what this increased baseline is for. And this just goes back to exactly what Bart was talking about. That's that 30% increase to reflect, again, that special performance. So you have your standard applications, you have your special applications, and you need to, again, redo your baseline. As you really go through the mix designs and you start pouring accelerated concrete, you can see here 25 MPa with 75% at 24 hours. That's going to have an updated baseline, which will have an updated CO2e baseline. So as you're pouring more and more concrete, the baseline will continuously be updated to reflect these special applications. And in the end, you will come up with a finalized baseline that will be used for your overall project. Now for this project, you can see what kind of impact the special application mix designs actually had on the CO2e baseline. So all these green bars here, those were the anticipated CO2 baselines based on anticipated volumes. And then as you actually factor in your special applications, all those accelerated mixes and high performance mixes, you can see that a lot of those values changed over the course of the project. So your anticipated baseline goes from 9,200 tons up to 10,600 tons, accommodating those special applications. So that overall is how you would set the baseline and the evolving baseline as you are using special applications. But then once you start pouring concrete, now you're looking at what is the impact of the actual mix designs that were poured for this project. So you go back and you look at it exactly, my 15 MPa, I had to use the Ontario Industry Average EPD mix design table from the Ontario report to really try to calculate what kind of impact those mix designs had on the MET project. So again, just an example, 35 MPa class F2, the mix that was actually used with a 35 MPa concrete with air, 25% slag, that was about the equivalent mix design that was actually shipped on this project. You would do that for every single mix design on the project, and then you can actually come up with your project CO2e. Now, I do have to mention that the mix designs shown in this industry average report are based on the industry average report. To actually look at what was shipped, I did require access to proprietary information, which will not be disclosed to specifiers or owners. So I looked at the table and which mix design most closely reflected the concrete that was shipped. Now, I did this a few months back, meaning that since then there's been a lot of developments. But ideally, you can simplify this entire process and improving the accuracy of it by having type 2 and type 3 EPDs available. So instead of consulting the Ontario Industry Average Report and trying to figure out what mix designs were actually shipped, our members do have type 2 and 3 EPDs available. That has to be discussed on a project level with them, but overall it will give you a much easier process because they can submit that information directly. So once you figure out your baseline, you figure out what was exactly shipped on the project, now you can calculate your greenhouse gas reduction. And all this information again is reflected in our guide as the step-by-step process. So you take your final CO2e baseline, which was just over 10 tons or 10,000 tons, and then you subtract what was actually shipped on the project with those optimized mix designs, and you get a GHG reduction of about 1,200 kgs or tons of CO2. And then to figure out your percent GHG reduction, you follow that formula. It's about 11.5% on the MET project. So 11.5%, which leads to about 1,200 tons of CO2 saved. If you look at what that actually means in a real world setting, you can actually consult the Natural Resources of Canada Greenhouse Gas Equivalency Calculator, which simplifies it in everyday terms. So 1,200 tons of CO2 is approximately equivalent to the annual emissions of the following. So 339 passenger vehicles, 259 homes energy use for 1 year, 741 homes electricity use for 1 year. So it really breaks it down in easy terms, but it is quite an impact taking 339 passenger vehicles off the road for 1 year. And that's again, not really considering carbon reduction goals on this project and just calculating how it all would have worked with a carbon budget. Now, if type GUL was available back then, you would have achieved about a 15.3% reduction. 1,600 tons of CO2 would have been saved on this project. and you would have taken about 453 passenger vehicles off the road, and all these other things as well. So overall, carbon budgeting is definitely crucial. If you look at your final baseline versus what was actually shipped, and you do that for every single mix designs, you can really see where you had opportunities to actually maximize the mix design. The greater the difference between your baseline and what was actually shipped, the more carbon savings you're going to be achieving. But going back and looking at the impact of each mix design paints a pretty good picture of how carbon budgeting really does work, and it gives the flexibility to the contractor and the ready mix producer to play around with the schedule and play around with those 140 different mix designs. And finally, looking at specifier considerations for this project itself, there was a pretty unique type of example. So 30 MPa class F1 usage example. F1 concrete was used, 4 different types of applications on this project. So first is the standard, which was about 1,000 cubic meters, and that would have obviously used the the industry average baseline, the standard one, and the mix that was actually shipped was very similar. So there really wasn't a lot of carbon reductions on this project when it came to the class F1 mix. This other mix, class F1 special, this was an accelerated mix design using set acceleration, which would qualify for the updated baseline. And overall, because the mix design was still optimized and performance admixtures were used to achieve similar type of set in cold weather, without really impacting the carbon impact, 23% would have been saved in terms of carbon reductions from the baseline. And then once you get into the accelerated strength development, so strengths at 24 hours, strengths at 48 hours, you can really see how much that special baseline impacts the carbon budget. So had we just factored in the standard baseline for this mix design in the table, these 2 mix designs, which make up about 47% of the volume, this mix design would have exceeded that value. You can see almost a 30% increase from the standard baseline and a 23.5% increase from the standard baseline. So if you just specify, standard baselines for mix designs, there's absolutely no way that every single truck will meet that over the course of a 3-year project. And that's very, very important here. So do not specify application-specific GWP values for concrete carbon count exclusively, but utilizing the concrete carbon project budget and balancing the schedule with mix design optimization, you still can achieve about a 0.3% reduction and a 5% reduction if you use those increased, that 30% increase in baseline to give you that better performance that the contractor requires. So this mix design really paints a very important picture that budgeting is the way to go, because you can optimize in the summer and the spring maybe, but when it comes to fall and winter concreting, you will need different options which will exceed the standard baseline. So that's a really quick overview of carbon budgeting and looking at a real life project. So 30,000 cubic meters that were poured on this project, 15,000 were accelerated. And if you don't balance your budget from the start and optimize your mix designs from the start, you're not going to be able to achieve those carbon reduction goals as the project really evolves. And the contractor, needs that flexibility to get accelerated mix designs, accelerated set mix designs, or even pumpable mix designs. All that has an impact on the carbon budget. So Bart, that's pretty much all I have. We do have some questions that we can answer.
Okay, and one I just wanted to hit off right off the top. Again, to be completely blunt, the cement and concrete industry has made a very dramatic push forward here with transparency. Again, our goal, if we go back, your example was from 3 or 4 years ago when there was no information readily available. Again, we did partner with the National Research Council to come up with these new industry benchmarks. We realized if we're going to get into true transparency that we couldn't do a national average, we had to do a region average, so that we're getting rid of things like different supplementaries, different raw materials, and we're looking at what's really available here in Ontario. So again, when you step back, EPDs, Ontario is not the leader when it comes to EPDs in the concrete industry. We have a number of members that have them. Again, we look at some US jurisdictions, we look at BC, a little farther ahead of us, but we're definitely going to catch up as the process goes through. There's over 30,000 concrete facility-specific EPDs in North America, and that is only going to drastically increase as we go forward here. And again, this is about concrete, so I won't throw too many stones, but again, you've got 3 primary construction materials. The saying goes, people who live in glass houses shouldn't throw stones. So again, what we're trying to do here is identify where our contributions are, and let's open up the discussions about how we can effectively make significant reductions out on the job site. So I'll put that same challenge back to the steel and wood industry to be just as transparent as the concrete and cement industry is being. Again, I saw a little article last week about the wood industry and whether their accounting is truly accurate or not. That's one of the frustrations that we've had, but this presentation is about our industry, so I'll leave it at that. But again, really what we're trying to focus on is let's have open discussions about what we can do and how we can make it effective. And this is going to be a big step forward.
Absolutely, Bart. So let's tackle some of the questions. We have about 10 minutes left here. So first, when will the Treasury Board specification be released, Bart?
Oops. Okay. So as I indicated, we are part of the challenge there. Again, we've been in discussions with them over the last couple of years, trying to look at how we can move the industry forward. We realize that as the most used construction material in the world, we need to be first and take significant steps forward. So again, we literally just produced for all 7 regions across the country that these new regional concrete averages that people can use in order to do these types of calculations. So in fairness to them, I know their goal is to still roll it out this year. I would expect that it will be actively used on projects starting in 2023. But again, they needed the raw data from us to create the baselines before we can get into the actual calculations that you've shown here. So it's coming soon, and as soon as they publish that report, we'll update our report to include the actual numbers.
Okay, perfect. Thank you, Bart. The next question is, or it's more of a comment and then a question. Aren't the baselines too generous? Even doing the case study in 2016 achieved a 15% reduction over these baselines. Great question. And I think if you go back to our previous webinar on September 20th, you're going to see how far we've come when it actually comes to the Canadian Ready Mix Concrete Association report, which was done in 2017. So our baselines are already 17 to 24% lower than that report. That's, again, just the starting point, and that's an industry average. There's, again, a lot more reductions that can be achieved by our members through Type 3 verified EPDs. But when it comes to the baselines, we definitely set them based on average, volumes that were poured and average SCM values from 2021. So there's no greenwashing going on, really. We try to set them as accurate as possible, and the reductions, again, are reflected from the CRMCA report. 17 to 24% is quite significant, and we're only going to improve as we, fully switch over to GUL, and we actually continue to provide this information to the industry. Bart, did you want to add anything there?
Yeah, I guess it really comes down to this project level carbon accounting is brand new for everyone. I fully expect that there will be ongoing meetings with specifiers and government agencies on how do we refine this. But literally, with the exception of we have 270 concrete plants in the province. It's a 2-digit number that represents the number of facilities that have Type 3 specific EPDs. You're going to see a dramatic increase in that as we go forward. And I think really what we would stress as the association for representing the concrete producers is let's start off, let's accurately quantify where we are over the next year and a half, and then let's look at targets. So again, even the idea of a 10% reduction from the baseline, again, when you have no history on that, there's always a little bit of hesitation. But really what moving to EPDs and to GWP values for individual mixes, it moves it to that performance world of, okay, we're going to set it, we're going to know what the number is, and we're going to actively discuss how we bring the number down. So that should promote better numbers going forward. And the other challenge that we see, as you said, the GWP values from 2017 versus 2022, they reduce significantly. Every time we update an industry average, it's only going to go one way, down. So reductions are going to be more and more as we optimize and get better and we improve our raw materials, then reduction targets are going to be harder and harder to hit. But that's pushing us all in the right direction.
Absolutely. Yep. And again, a lot of this is voluntary. We as an industry have taken these steps since 2017. Nobody is forcing us to do this right now. It's obviously coming down the pipeline. But we do want to be transparent, and it's still important to achieve the performance of the concrete. It's not all about carbon reductions. You still need to achieve your strength, your durability. We want buildings to last. So that's the first focus, and now we're adding this other greenhouse gas reduction impact. Continuing on the questions, can you please explain the types of EPDs and what is the preferred EPD level as well? It's two different questions in one, Bart. I think you covered this already.
Yeah, again, we've got what we've produced as an association is the industry average data. So again, it's using a hypothetical average concrete plant. Then you move to type 2, which is facility specific but not third-party verified. And then you move to type 3, which is really what we've seen from both the US government and the Canadian government is a very, very strong desire to move to type 3 EPDs as quickly as humanly possible. So I think we're going to see a significant advancement. We've seen quite a bit of it in the United States already. That's why there's over 30,000 EPDs for concrete. Again, a lot of US states are a little farther along than we are in this process, and I think we're going to catch up very quickly. So ultimately, the engineer in me says, yes, the most accurate number is the one that we should be going with. So I think that's why we're not pushing back on type 3 EPDs at all. It's just the practical aspect of getting the industry up and running with them that we'll have to address over the next year or so.
Okay. I can tackle the next one. How is all the information presented today being shared with the specifiers, consultants, and developers? So first of all, we finally released our guidelines. So now we have a document that we can showcase to the industry. Concrete Ontario has done numerous presentations already over the last year. So this is, again, nothing new for us. Lots of presentations. We're in talks with the Ontario architects to attend their conference later next year. We're going to be at the building show, the Canadian Concrete Expo. So lots of presentations, and again, on-demand presentations. If any specifiers or architects want to reach out to us, we're definitely willing to have that conversation and outline all this information to them. Next, who will be performing the carbon accounting?
$1 million question. So this is one we talked about in the presentation, the need for communication. This is not as simple as your example showed. It's not as simple as just setting a budget at the start and we wait till the last, we get to substantial completion and someone submits a spreadsheet and we go, perfect, we're done. This is one of those things where there's basically weekly or monthly ongoing evaluation. If you're doing it right, you're evaluating it the whole way through. So you're going to have the consultant who is looking for the carbon reduction goals. The primary information is going to be pulled together by the general contractor and the concrete producer. So the general contractor has control over the schedule and what's cold weather, what's warm weather. That flows out from the project timelines and what needs to be accelerated and doesn't need to be accelerated. That flows out from their overall approach to the project and what the financing requirements are, how quickly the building has to be up and in place. So again, it's going to be, bulk of the work is going to be on the contractor and the concrete producer with basically information going back to the owner to show we're on target, we're halfway through the winter. We're a little over our target right now, but we know we've got another 8 months, and in the summer we can increase the amount of supplementaries and get below that target. Those are the kind of discussions that we're hoping to see people have. But we are in an environment, quite frankly, where everyone is short on labor. It doesn't matter what industry you're in, and this is going to take more time. So from a project management standpoint, we're adding in a new component for evaluation.
Definitely, as you said, it needs to be monitored from the beginning of the project. You can't wait till the end and then try to figure out what the numbers are. You need to continuously update that baseline to see where you stand, and then you can actually optimize future concrete pours to lower down those impacts. You will be taking a hit, obviously, in the cold weather concreting climates and timeframes, but overall, it needs to be monitored throughout the entire project.
Yeah, and again, there's options. Like if we go back to the cold weather example, if you want to use 30% slag in the winter, you can, but it's going to have an impact on the contractor, because now the contractor is going to have to maintain heating and hoarding. And so if I'm picking on the GTA area, when we're getting down to -10, -20 routinely throughout the winter, you could still use higher supplementaries. You can still have a lower GWP value for the concrete, but it has an impact on the construction. So now we're going to bring in natural gas or propane heaters, and we're going to have to heat that concrete for a longer period of time before we can stop. The guide talks about the impacts of curing and using higher supplementaries and what impacts that has as well. These are all the interactions that basically the project team has to walk through. It's like, okay, the great thing that we've done here is we've now set a benchmark. And now we have tools to identify where we're at. And now we can have discussions amongst the entire project team on, okay, our project is 18 months. It's starting on July 1st. And here's our rough timeline for concrete pours. What do we think is going to happen? And then evaluate it week by week or month by month to see, are we on track with what we want? So great opportunities, but definitely more work.
Okay, so we're almost out of time, so we'll take one more question here. There's a bunch coming in. Again, thank you very much for the questions. We don't have time to answer all of them, but we'll tackle one more here. How are you making your members accountable? Are they going to be willing to provide EPDs type 2 or 3 throughout the project, or will it be a fight to get these? So that sounds like a contractor question.
It could be an owner question too.
Yeah.
Again, from an industry standpoint, that's why we've supported coming up with the benchmark numbers. Again, in discussing this we've had lots of discussions over the last 2 years with both consultants and large general contractors that are well ahead of the curve when it comes to this issue and have been pushing the industry on this. So again, as an industry, we're saying that we're going to be transparent and we're going to be accountable. We are not going to disclose mixed proportions. That's a non-starter, but we will produce EPD documents to show what the impacts are. That's the performance way of addressing it. So again, we're going into a new transition here. So there's going to be some challenges. That's where, again, as an association, we're happy to help out when it comes to, if you're a contractor, a consultant, or an owner, we're more than happy to get involved early on in the project and provide feedback on how these things are going to work. It's a brave new world for all of us with something that's completely new. We're adding in a new performance requirement that typically hasn't existed before, but there is a need to address carbon reductions worldwide, and this is a very significant step forward. We have to measure it, and we have to talk about how we can reduce it.
Absolutely. So thank you very much, Bart. Again, great information there. I think we've tackled everything today really well. I want to thank everybody for attending. The document, again, is available in the handout section. Please feel free to download it. The email will go out tomorrow with the recording of this presentation, along with a PDF copy of it. Check out our new guideline. If you do have any questions, please reach out to myself or Bart. We'd love some feedback on about how we can improve it. Things are steadily changing month over month, and we want the best possible document for owners and specifiers that they can actually rely on. So again, thank you very much for your time, and we hope to set up a webinar in the near future to provide an update on all this stuff and our new initiatives. So thank you. Have a good day.